Thank you, Tricia. Appreciate it. I hope everybody can hear me. So I think Tim touched upon a lot of what we are doing in Presto and how Presto is free and various senses of the word and open. And then more recently, just now, David has been talking a lot about industry trends and hardware trends. So hopefully nothing in this talk is like super surprising to a lot of you, but I just wanted to bring all of this together and put a kind of a cause-effect relationship. Essentially think of it as the paper trail between what's happening and what we are doing and why we are doing, right? So hopefully this all makes sense. I'll get started. And I think there is a Q&A. Please feel free to ask questions. This is a live session, and I'll be happy to take them maybe after this talk, because time is kind of a little short. Okay, so let's see how kind of the things are evolving around us, right? And I think I wanted to break it down into three things: the use cases, the environment or the platform on which we are, and the industry. So let's go into. I think people have been touching about this at various points, but A is complexity. I think complexity of our data has increased. Like there's a lot of, I think David Cohen and others talked about it. We have the nested repeated data types. ML has like thousands of features, and these tables are really, really wide. Query patterns are getting more and more complex. People want to do very interesting things with data, like graph mining and all that kind of things. BigQuery is doing ML within SQL, for example. Time series is becoming more and more common to be embedded and stuff like that. Machine learning is becoming pervasive, and this impacts us in very interesting ways. Like I think one way to think about it is the same data or the same infrastructure. How can we unify the ML and the analytics into one umbrella? Because there is really a lot of power. Pretty much all of ML depends heavily on data. And also, like, how can we leverage ML in analytics? And I think I'll talk a little bit about that. That's such an interesting area. I feel that is not kind of sufficiently pursued. Privacy and security is becoming really, really important as the world progresses. Huge amount of user data is being generated. All companies, including Meta, our users are much more privacy conscious. We are much more privacy conscious. Security of our systems is really becoming important, and this has interesting implications on open source systems. I don't know if a lot of you have been following about some of the talk of how introduction of kind of very carefully social engineer attacks are on the rise and things like that, right? And then with the increasing data, one trend that is particularly interesting, I think, is showing the data externally. So if you think of what LinkedIn is doing with Pinot, or what YouTube is doing, like it's essentially analytics, but it is analytics at a scale we haven't thought of before, because those analytics engines are essentially serving millions of queries per second. So we are kind of getting into the transactional domain in terms of the kind of QPS and latencies that are required, but it's still analytics. If you think about the like count on YouTube videos, for example. Right? And the last one is about scale and performance. The amount of data is huge, which means there's a tremendous pressure on all of us to kind of continue to decrease cost per byte, cost per watt, and CPUs are like Moore's law. We are hitting Moore's law. CPUs are not getting faster, at least not at that frequency. Horizontal scale is becoming more important, but that has kind of interesting constraints in terms of networks and disaggregation. So the performance and efficiency at scale is kind of something that is super important to all of us, right? Or most of us. So now let's talk a little bit about the platform and how the platform is changing and how that becomes interesting for us. The first one is the migration to cloud, and then pretty much everybody is on the cloud or moving to the cloud, and like the cloud introduces a lot of freedom, but it also introduces a lot of interesting challenges in terms of like disaggregation of storage, and how you can elastically scale your clusters up and down. The hardware heterogeneity, there's a lot more flexibility. You can actually save money by like doing per minute billing, and I think introducing per second billing. So, and specialty hardware is becoming more easily available. So for example, Google has been kind of very good about investing very early and heavily in TPUs, tensor processing unit, which are kind of a specialized hardware for ML. A lot of companies are using GPUs. GPUs are much more easily available on the cloud, and this brings some interesting challenges and some interesting opportunities. How to leverage this kind of architectural changes that are happening. If you think about the classic databases like Oracle or SQL Server or Teradata or Netezza, those architectures are increasingly challenged as we move to the cloud, and new players such as Snowflake, who are more suited for this kind of architecture, are clearly kind of taking over. I think some of the reInvent announcements, for example, Redshift serverless, kind of an interesting, because we can see that like even kind of entrenched players in the cloud environment such as Amazon originally had analytic databases that didn't quite fit into the cloud, and they're trying to move in that direction. And let's now talk about our industry, like which I consider kind of the big data / data analytics industry. And there are a lot of things, interesting things happening here, and then I'll just give a few examples. Like first is, I think there is a significant amount of fragmentation in the OSS part of the industry. Like we are all aware, like there are many query engines. We have Presto, Spark, Pinot, etc. Metadata is rapidly getting quite interesting. I think we all recognize that metadata is kind of critical if you are to have a really competitive offering, but our metadata environment is kind of very fragmented, right? We have Iceberg, we have Delta Lake, Hive, Metastore, Hoodie, etc. Now, another big challenge is that each of these engines come with their own dialect. Like it's very hard to use multiple engines in a cohesive whole. So you might want to say, hey, this engine A is good at interactive, engine B is good at batch, but how do you make, but this is not a discretized problem. An engine C might be good at streaming, but typically a user would start with writing an interactive query, then try to schedule that query in batch mode, and then maybe try to put that query into a real-time engine. And because these engines are not consistent, they have different eval engines, they have different dialects, it becomes, and often they have different ways of addressing metadata, it becomes a big friction point, right? The second aspect, which is kind of interesting, is closed and mixed source vendors are coming up really quickly. Like we have talked about Snowflake and what they're doing. Obviously, Databricks has a very interesting kind of semi-open offering, and they have done a bunch of very exciting work around, for example, native code acceleration. And we'll talk a bunch about that later in this. And but that is not really available to the open source community, right? So which creates an interesting challenge. Like where do we go from here? And then finally, all the cloud providers, they have their own kind of dedicated teams building their own proprietary engines, which are completely closed ecosystems. Like if you take Redshift or BigQuery, for example, you don't get to use their file formats directly. You don't get access directly to the data. You have to go through the APIs. The APIs impose a lot of restrictions. There's the payment model involved, and so on and so forth. So there are definitely challenges here on the industry. But let's talk about, hey, Presto is free in many senses of the word, as Tim pointed out, and it's fully open, and we have a very vibrant ecosystem. So why do users sometimes choose these closed ecosystems? So thinking about it, I think it comes down to kind of three main things. One is that the user experience of this ecosystems is a lot better sometimes because it's very tightly integrated. It provides an end-to-end consistent view. It is a fully managed. There's dedicated support. There's constantly improving based on it, and there is a certain amount of polish, I want to say, to these experiences. The second one, and this is often very important, like going back to, for example, some of the recent TPCDS blog posts back and forth that I don't know if people are following those between Snowflake and Databricks, for example. Performance at scale is becoming super important, and this is like databases live by the benchmark and die by the benchmark. I think there's a saying, right? And increasingly, the closed ecosystem systems actually are very, very heavily investing in performance. Like they are investing in optimizers, they're investing in like native code acceleration and a bunch of other things. They are extensively doing performance testing, benchmarking. You can see a lot of results of that in the recent blog posts that have been published by Databricks, for example. And the last one is about control, right? The users often sometimes, like, you want to say that, hey, do I have a clear path to success here? Like, is this a long-term viable product? Or do we have a published vision, have a published roadmap? Do we have a tight customer engagement? So this is a lot of, there is a lot of kind of, what should I say, the human cycle associated with this, and kind of the predictability of that cycle is very important for a lot of our users. So how does all this impact Presto in particular, and maybe the open source analytics environment in general, and be like, what are we doing about it? What can we do about it? So let's talk a little, let's give a few examples of what we're doing about it. Probably none of these examples are super surprising, and we'll be talking about a bunch of this going forward, but it might help to kind of link what we are doing to why we are doing it. So hopefully this sets up a context, right? So here is a semi-random list of projects that Meta has been executed on, for example, and I think with a lot of help from the community. So we have been executing on, most of these are kind of community open source projects that we have been executing on them together with many of our partners. So I'll just like to run through some of these and how they kind of link to the overall picture of how we can kind of really truly kind of move the needle on the open source data analytics ecosystem. So I think we have talked about Raptor X a couple of times before, mainly the storage disaggregation, and as we talked about in the cloud, right, is becoming super important, and Raptor X kind of makes a very stance there that, hey, we are going to integrate with the kind of the integrated metadata and the disaggregated storage, and yet we will not compromise on interactive performance and scale. And there are various techniques of how we can do that, like through caching, metadata, partial results, etc., through better affinity, and a bunch of these techniques. And I think Kay and others will have a talk later on some of the newer things we have been doing, like, for example, speculative execution and load balancing and Raptor X. And this space is evolving in interesting ways, right? And we continue to make things better. One recent thing that we have done internally, for example, is support for real-time data. And this is really cool because we can query the data as soon as it lands, and we see kind of freshness of somewhere between 30 seconds to 1 minute, for example, in some of our internal applications. Sapphire, again, I think we have talked about it a couple of times. This is basically take the Presto engine, refactor the front end and the back end, and run it using Spark. Now, this has a ton of interesting advantages. The first one, as we said, direct convergence. This is important because we talked about the user experience end-to-end being smooth. So I'm writing an interactive query. I want to now run it on batch. I want to run it, and I want to make sure that it behaves exactly the same way, right? Sapphire achieves that. Resource convergence, like we are using Spark in an environment in the fixed resource pool. You don't want to have two resource pools to manage between Presto and Spark because some of your retail is already on Spark. This makes it a lot easier. And finally, performance at scale. When you're running really large, long-running jobs, Spark's architecture is fundamentally better suited to that kind of job, especially if you're running on, spot instances or some kind of unreliable, semi-unreliable hardware, which tends to be a lot cheaper. This is clearly a much more scalable and kind of reliable way of running. And we are seeing the effects of that at Meta right now. It is running in production. Okay, Velox, like, I think there are a bunch of talks on Velox. I'm really happy to see the amount of excitement it has generated. We will be talking more about, the kind of CPU and memory wins and latency wins we are seeing, but there are other important aspects of Velox, and I want to touch upon those. First is that it allows better convergence, right? Both on eval. So now we can have the same eval running on Spark, on Presto, on like streaming applications, on MLP processing. So this is an interesting one. And I think this, at Meta, actually, this has generated a lot of excitement. And I do want to mention this, that a lot of ML is about data prep and data serving and, data generation. So if you look at the ML lifecycle, like this feature engineering, there is ML training, and then there is ML serving. And there is a strong need there for some kind of a unification mechanism that I write the same business logic once and I can use it at every step of the ML lifecycle. And we are trying to do that, right, using Velox as the underlying framework. And this has really taken, this has kind of gained significant traction, right? And I think Dave pointed out earlier, another advantage of doing the eval convergence is that you can now do all of these hardware accelerations and, code gen and all those techniques once, and all these performance benefits are automatically available to all the engines that use. So for example, if ML kind of introduces GPU accelerated version of certain functions in Velox. Hey, tomorrow Presto and Spark can use that, and they can use it on the cloud, which I think is super cool. And then finally, dilate convergence, right? So if you use the Velox eval, you automatically get, a standard implementation of the ANSI compatible Presto SQL Direct in terms of functions and operators. And this is a pretty big deal, because then if you're building a new special purpose engine or a new special purpose kind of program and you want to make sure that it is fully compatible, you can just integrate Velox and kind of achieve the same purpose. Tim and others have talked about kind of the shared, the multi-coordinator model. This improves high availability, allows us to scale better. As you said, like with large data growing, scale is becoming increasingly important. And similarly, like cost and users are more and more cost sensitive. And for example, SPAC actually allows us to use Spot, not only kind of better load the machine, so you can kind of run your clusters a lot hotter and save money, but you can also potentially make them much more amenable to elastic resources like Spot instances, for example, which I think is another kind of knob you can tweak to kind of improve your cost or kind of power per watt and things like that. There is a fair amount of investment going on in the optimizer and things like, smarter rewrites using history statistics. One interesting aspect, I think we have talked about a bunch of these, and we need to bring a lot of the existing literature that exists in the optimizer space into Presto and open analytics in general. We do need to have, this is where the metadata integration comes in, because this requires a lot of rich metadata and rich history and things like that. And we need to figure out how to do that without, our current fragmented kind of metadata system. And hopefully, one of the things we want to do is align on what metadata APIs are available and how to use those APIs so that the engines don't have to, redo this a lot of times. One aspect that I feel is currently underexplored, and we are beginning to scratch the surface of it. I say, hey, how can we be smarter than simple heuristics? Can we introduce ML-based techniques like hyperparameter tuning? And this is kind of a very early stage experiment. Hopefully by next PrestoCon, we'll be able to share some interesting results or some interesting trends here. Materialized views, again, there is a talk on this. Rohit and others will be talking about it. This was a common feature available in most databases. We had been missing these features, and now we are adding that. Again, requires deep metadata integration. I keep coming back to this, but metadata is kind of at the heart of the system. And right now it works with Hive meta stores, and we are trying to integrate that with Iceberg, but there are definitely challenges that are introduced with this metadata fragmentation. One thing that we do want to work on, and I think people might have seen the announcement from AWS on this AutoML kind of based materialized views. This is something that we hope to build in the future, and I think there's a lot of potential there about not just materialized views, but kind of automatically building secondary structures for query acceleration based on query patterns. Let's put it this way. There's a lot of work that we should be doing here. Rich types, as we say, like the query complexity is increasing. We have got geospatial support. Presto has really good support for nested repeated data types and kind of with lambdas and all those functions. We have an internal GraphSQL at Meta, which hopefully will open source at some point, which is actually an interesting take on how to do interactive graph queries by leveraging Presto as the underlying system. And we are working on a bunch of other kind of interesting type system enhancements, such as distinct types, enums, and name structs. Hopefully, some of this will kind of come to force and can be reused better. One area I do think that we need to do more here, like we have missing bits, like time series. I think JSON and semi-structure can be handled better. Like I think Snowflake has done a good job here, and we should look to the industry to see what we are doing there. And then finally, expressibility. We do think that there is a gap here in terms of what we can do. Obviously, Velox helps quite a bit, like because if you write a particular function business logic in Velox, then it is available in all the engines that use it. But we do need a strategy for like covering the long tail of user connectors. There are like 1,000 etc. Kind of operators and functions in Presto. We cannot possibly port them off all in a day. So they will be living in this kind of multi-language world in a while. And portable UDFs help a lot because they run across engines, so you can write it once and run it in different engines. They support multiple languages, so you don't have to port to C++ or Java. You can write it in Python, for example, and have that available, though probably don't do that for performance reasons. Cross deployment. So this allows you to iterate on your complex business logic independent from the engine release cycle, so you can write your own UDF on your own UDF server, and you can still continue to use the same version of the engine and benefit from your new business logic. So I think I'm right on time here. The key takeaways, core competencies, like this is the number one thing that we're investing in, and this continues to be scale, efficiency, latency, kind of elasticity, disaggregation, all this stuff. One very critical aspect that I feel like we don't pay as much emphasis on, and we should, and hopefully of some of our actions have demonstrated that, is building shared foundations, shared components, shared capabilities, shared APIs. How can we, reduce the number of variations of eval engines and SQL dialects and meta stores and things like that. And Tim kind of emphasize this also, that this is really important that we collaborate together on this. Together, the only way to win this is really to work on the same things and work on them together, because no single entity can actually take on the super large kind of proprietary vendors. We do have to work together on this, hopefully collaborating on Velox. Velox is a great example of how I can see, like we started it fairly small, and then now like we, I think, have like half a dozen companies collaborating on it, which is really awesome to see. And the last one, again, like we have to move the state of the art, and the innovation is key here. We do need to rethink our assumptions. Like, hey, are we, like, what would we do if it was day one? I think it's important. And then kind of use that on the basis of keep track of what's happening in the industry, and start the right initiatives so that, we can continue to lead the way here. And we do have a ways to go to catch up and lead the industry, but hopefully we're moving in the right direction. And that's it. Yes, we're hiring. Thank you. And I'll happy to take questions often. All right.
Hey, Biswapesh. All right. Thanks for that awesome talk. It's funny, I referenced the TPCDS benchmark in my session. Girish and I talked about it earlier as well, about some of the closed source stacks, if you will, whether it's the data warehouse or whether it's on data lakes. You talked about a lot of innovations that are coming up. Obviously, Velox is the core library, which will be used across many different query engines. What is the most game-changing innovation that you think will help with that TPCDS benchmark and really drive that from a Presto open source perspective as you look at SQL? There's Velox, there's the optimizer you talked about. Is there something that you think is truly leapfrogging from a Presto or a SQL analytics perspective?
But one area I think we haven't dug into, obviously, like the eval and the optimizer, kind of the distributed execution is really important. One aspect I think that we might want to poke at more is the adaptive execution. And this, like we have started making small progress on this with, for example, leaf level speculative execution that, we are beginning to experiment with. But based on my past experience, I think with complex queries, it is almost impossible to predict when you start the query exactly what the cardinalities are and exactly how the query will behave and exactly which keys will skew and things like that. Right. So Spark has made actually some good progress here with, for example, the Spark AQV. I think we don't quite have that in Presto, and AQV is actually a pretty hard problem, and current Presto's architecture makes it difficult for us to have AQV because we have the static DAG. Let me put it this way, right? Whereas AQV is fundamentally a dynamic DAG. And this might introduce interesting changes into the architecture, such as shuffle disaggregation and kind of the ability for us to merge and split. So this is maybe not a very TPCDS specific answer, but in the real world, I feel like TPCS data set don't really have skews, for example, right? But every real world data set that I have dealt with ever has skews. Right, and TPCDS is fairly easy to predict cardinalities, but in the real world, cardinalities are really, really hard to predict. So this is, I think, an underexplored area. We do want to invest in it. So far, I think the investment has been very minimal, but I'm hoping that we'll change that next year. Let's see.
That's great. That's great. And the other question that we often get from the community is with Velox and Prestissimo, and there's 2 great sessions later this afternoon which go into more depth. But any sort of forward-looking comments on how much this will help from a bandwidth or throughput perspective, right? The goal here is really to reduce CPU utilization and to do more with less. Any early results that you've seen, or any goals that you want to share?
Well, I don't want to steal Ori's thunder. I think Ori is going to present some interesting results, but I would say it is early days yet, right? We have just started, shadowing kind of production workloads, and we are seeing some substantial wins in somewhere between like 2 to 10x depending on the workloads. Again, like Ori will probably, and others, I think, in fact, your team is probably also going to talk a bit about that. So I'm looking forward to seeing those numbers. I'm reasonably confident that those numbers will be really good based on what we have seen so far. But again, like I would hesitate to speculate how it will impact them.
That's
across all the workloads, but I am hoping at least 2x, presumably more, and so far our experience are looking quite positive, I want to say.
That's great. Well, it's we don't want to steal their thunder, so that's a good preview or into the real movie that'll happen later in the day. Thank you again for the great session. Open does matter. We talked about it in the keynote this morning, Girish and I. The theme kind of continues in your session, where it is about open formats, improving on that, no lock-in, having common components that can be shared across, doing more with less. So thanks again for the great session. And
I did want to quickly mention that I didn't talk about formats, but watch this space. We might do something interesting here.
Coming soon at a theater near you. Sounds good. Thanks so much, Bisha. Patricia, back to you.